rebirth of American manufacturing is underway. From three-dimensional printing in New York's Big Apple to green remanufacturing in America's Deep South to electric car production in Silicon Valley and even advanced robotics in California's Gold Country. A new and innovative Made in the USA is back.
Hi, I'm Mary Owens of Owens Estate and Wealth Strategies Group. We are all aware that over half a century ago, the United States was known for its manufacturing might. Matter of fact, we had companies that were so synonymous with that, they became household names. And their names were synonymous with quality and ingenuity. And from these companies grew the wealth of the middle class. That wealth is what created the balance in the United States some 40 to 50 years ago. The U.S., however, while we enjoyed all the benefits from manufacturing exploding, we allowed things to start to occur when we weren't paying attention. So yes, the U.S. did fall asleep at the wheel, and the consequences were they weren't so pretty. Nearly 40 years later, after we witnessed which was a terrible fall from the heyday of manufacturing, the tides are beginning to change once more. The significant portion of the new plants utilize large numbers of robots to share in the labor cost. Now the main factory workers are quality control inspectors, specialty chemical workers, engineers, and computer technicians. These jobs are safe, clean, and very much middle-class wages. Wages overseas are still cheaper than a U.S. worker when you average them out on a dollar per hour basis, even though they have been rising dramatically and are estimated to continue to rise dramatically in the future. However, the real issues when we look at wages are how productive are their workers. If the worker is able to accomplish more per hour, they can still compete. Now, this is where the U.S. tech industry has been a blessing to the United States in enormous ways, but now it is the catalyst that is going to bring back U.S. manufacturing back home. It is via technology that we are revolutionizing the manufacturing floor, allowing a higher paid worker to actually compete and be more productive. This productivity is so important to the middle class. This will allow a livable wage and be able to give the middle class a badly needed break. They need their jobs back. Tesla Motors is leading the changes in the auto industry with its new revolutionary vision in both factory design and with the manufacturing processes themselves. It all began when Tesla purchased the old GM Toyota factory in Fremont, California in 2010. Tesla is constantly striving to improve process efficiency by utilizing automation to the fullest. They have about 160 robots combined with latest technologies you can find on the planet. The robots are able to do very diverse tasks with extremely high levels of accuracy in their motion, in a process that is 100% repeatable. Tesla uses humans where there is a value for that intelligence and the ability to reason and make decisions. They are located right in the middle of Silicon Valley, where some of the world's best universities, such as Stanford, UC Berkeley, and UC Davis, are close by. This U.S. talent allowed Tesla to be the very first successful auto startup in America in more than 90 years. In addition to robotics, there are 3D printers, making laborious molds that have been remade for refractionist airs are a thing of the past. With a push of a few computer keys, designs for injection molds can now be changed in the matter of hours, not months. And thoughts for new designs can be tested in weeks, not years, at minimum cost. But these new technologies are also causing innovation and creative thought to soar and can be created with a minimal risk of capital. When we first started studying the possibilities of manufacturing return back to the United States, which occurred actually several years ago, the tide then was a very, very slow stream. We were very encouraged by seeing multinationals begin to name that we're going to actually move a portion of our manufacturing back to the U.S. But over the last several years, that slow trickle, well, it's now becoming a river. And that river is building with force every day. We are beginning to see every week more companies announce that the U.S. is a friendlier place to do business, and they're deciding to move manufacturing back here. So the United States is once again able to compete on a global basis right here on its own soil. We are in NoHo District of New York City at the MakerBot store, and Jennifer Howard, who is the Public Relations Director, is going to go over today their various products of 3D printing. Hi Jennifer, how are you today?
Good, how are you?
I'm doing well.
So welcome to the MakerBot store. We opened the MakerBot store in September of 2012, and we opened it because at that time 3D printing was a little bit of science fiction to some people.
And to many people it still is. They have no idea what it is and the potential of your products.
Right, so we opened the MakerBot store. This is the first one in the whole country. We now have 3 of our own in Boston, Greenwich, Connecticut, and New York City. But we opened this store because we wanted people to be able to see and touch and feel and even smell 3D printing.
Tell us a little bit about your product and what it can make and its potential. The potential is what's so fascinating.
Yeah. So 3D printing has been around for about close to 30 years now. But up until 5 years ago, it was in the industrial sector. They were large, huge 3D printers in a room with a specially trained technician, and they cost hundreds of thousands up to millions of dollars. 5 years ago, though, MakerBot came on the scene. Originally, we built our first 3D printers and we thought, oh, it'll take a couple months to sell them. They sold out immediately. So we knew we had something.
Wonderful. You definitely had a product
Yes.
people wanted.
Yes. So in 2011, the technology transformed and we came out with the MakerBot Replicator, which is the first fully assembled MakerBot Replicator 3D printer. And when we did that, there was a big shift in the market. So traditionally, our first customers were kind of those DIYers and the people who could really create something with their hands. But when we came out with this ready assembled 3D printer, the market shifted and all of a sudden engineers and architects and industrial designers and artists and entrepreneurs really started to pay attention. And they said, I can afford a MakerBot. Instead of going and spending $6,000 to have something prototyped and wait 3 weeks for it to come back, they could spend $2,800 and buy a MakerBot and put it on their desktop and iterate over and over again.
Now these applications you're talking about, all these professionals and engineers that are using them, what is their most common application? Is it a prototype example, the type we have right here, where we have the house design and the homeowner can look at it and say, that's what I'd like to have?
That's a very big application of 3D printing is prototyping. So we do have the engineers and the architects and the industrial designers that are creating new products, and they need to test those products, so they need to make them. So 3D printing is a great way to do that. We always say that MakerBot is an innovation company, and we innovate so others may innovate. And part of that is an iteration process. So when you're designing products, you need to change them, you need to modify them, and you need to do it over and over again until you get it right. without 3D printing, that process can be very expensive.
Extraordinarily expensive and time-consuming.
Time-consuming, yes.
Absolutely.
Yes, so having a MakerBot on your desktop makes that iteration process so much faster.
Could you explain that process? You have a 3D printer hooked
Sure.
up to a computer and a program. Explain the process of how easy it is to change what the outcome is going to show up here.
So 3D printing is really simple. There's actually 3 ways to create a design to 3D print. You can design it yourself using a CAD design program, a computer-aided design program. Autodesk has great programs. There's also a lot of free programs out there today. There's Tinkercad and SketchUp. There are apps for your iPhone that you can use, or your smartphone or your tablet, that make 3D design really simple today. So that's one way you can design it. The second way is that you can go on the internet and you can find ready-made designs. So say you need a new phone case, but you're not a designer, so you can go to a website, like we own a website called Thingiverse that has more than 300,000 downloadable digital designs. And you can go and you can say, I want an iPhone 5 phone case and I'm going to design it this way, or I have a Nokia phone and I want to design it this way, and then you can 3D print it within a matter of minutes.
And personalize it the way
And
you want.
personalize it, absolutely.
Put your name on it, put a logo on it,
Right.
do anything that you'd like to do.
So this is really personalized manufacturing. The third way is to scan an object. So say you have a physical object, you're an architect, and you have a beautiful piece of architectural molding that you would like to replicate or use that design somehow. You can actually scan that, and within a matter of minutes, you'll get a digital file that you can then 3D print. So 3D printing has come a long way in creating the designs. The actual 3D printers themselves are now pretty simple. We have material inside the back here called MakerBot PLA, which is a bioplastic. It's actually derived from corn.
So non-toxic.
Non-toxic, very, very safe, really consistent, great material, and really easy to use. One of the reasons that MakerBots use PLA is that we are all about 3D printing on your desktop. And when you're 3D printing on your desk, you want to make sure that that material is really safe. It's easy to be around. It's easy to work with. So PLA is a great product. And I mentioned earlier that you can even smell 3D printing when you come to the MakerBot store. And with PLA, it's because it's derived from corn. It actually smells like waffles when you're 3D printing.
It's going to get you hungry in the morning.
So what it does is the PLA comes through this little guide tube right here. And it actually, this is the extruder, and it actually gets melted in the extruder. And then it draws a picture. Here we started one here. So it draws the picture and it draws it over and over again, layer by layer, and it builds the object up until you have a full object.
So as this is printing, you actually can see all the internal structures and the internal inside the product itself. You'll actually be able to see how it's building walls in this particular case, and a fireplace and the like.
Absolutely. So the great thing about 3D printing as well is that it's great for the classroom. It's a great education because now students can actually see what does that combustion chamber look like in an engine? What does a house look like when it's being built? So they can get a much better understanding of the physical relationship between objects.
So dissecting a frog in the classroom is going to look a little bit different now.
Actually, it's funny you mentioned that. We have a program where we're putting MakerBots in schools called MakerBot Academy, and part of that program is developing 3D printing curriculum for teachers to use. And last fall we introduced a dissectable frog that you can actually 3D print, and we like to think that we're helping save some frogs.
And some girls that are a little bit squeamish about
Yes.
taking apart that frog.
Yeah.
Now, the other applications, we have talked about professionals and engineers. What about the home market?
So the home market is really starting to evolve right now. People a few years ago when MakerBot first started, they would say, what's 3D printing? And then about 2 years ago, people would say, oh, I've heard of 3D printing. Last year was kind of a change where most people would say, oh, I've seen a 3D printer, at least on TV or something. And now we're getting to a point where changing that rhythm, that maybe you might know somebody that has a 3D printer. Pretty soon there will be the kid on the block that has the first 3D printer on their block, like very much like the Apple computer going into the home. We actually see the transition of 3D printing to be very, very similar to how computers and 2D printing went into the home. So you think about computers 20 years ago, and people would say, why do I need a computer at home? I have a calculator. And now we're carrying computers in our pockets because they're our smartphones. They're more powerful than they ever were 20 years ago. And people can't imagine their lives without a computer, right?
Absolutely.
So
life doesn't function without one now.
So 3D printing is really going that same direction. Once you bring a 3D printer into your home, it's hard to imagine life without it. You can put it in your kitchen, you can put it in your kids' rooms or their playroom, you can put it in your workshop or your garage, and you can start making things. So I needed a doorstop the other day, and I 3D printed one. My dog was pushing on the door, so I 3D printed one and problem was solved. I need a new phone case, I can 3D print one. We have a friend of mine, actually, she had a challenge with her husband. They were building new bookshelves, and it was the kind that has the little pegs that go in the holes to hold the shelves up, and they were missing the little pegs. So she bet her husband that she could 3D print them faster than he could go to the store to buy them. And he came back an hour later with a baggie of 20, which they only needed 3, and she had already 3D printed them and fixed the shelves.
Problem solved.
Problem solved.
Now, the innovation that comes with this, that's the part that fascinates me. I've noticed that some of your customers are using in the home, but they've turned them into a new business without even the intent of that. The gentleman that had the part that he made for the Apple iPhone, when you had the credit card swipe, and it was always twirling. I've had that frustration myself.
It's called Square Helper, and Chris Nelms is the entrepreneur that created that. He was a musician, and he was actually selling merchandise, and he was using the square, and when it spins the wrong way, it doesn't capture the credit card information. So he went home and he designed this little foot to hold the square into place. He went out to go actually have it prototyped by a service, and they wanted about $6,000 to prototype it, and it was going to take 2 to 3 weeks for it to come back to him. Instead, he went and he bought a MakerBot Replicator desktop 3D printer for a lot less money. This is $28.99, and he started small-scale manufacturing on his MakerBot. When his volume went up, instead of going and injection molding his piece, he bought more MakerBots.
So he actually, out of the first investment, not only got his prototype, he got his manufacturing plant right out of his home.
And Chris is an interesting story too, because his business is really growing. There is a scale-up factor that is probably around 30,000 units, I believe, that when you hit that factor, you can go to the injection molded area. It could get less expensive. But when you're talking about smaller numbers and you're doing custom manufacturing, it's much more affordable to do it with a 3D printer.
Especially if your design is maturing and changing on a regular basis.
Exactly.
That injection mold, once it's gone, it's an expense that's been totally wasted. It no longer works.
Right. So with Square Helper, that's a really great example, because Apple changed the location of the phone jack.
Yes.
And so when they did that, he just went onto his computer and tweaked the design, and in a matter of minutes, he was up in business
His
again.
product was ready once again.
It was ready to ship. If he would have gone the traditional route of injection molding, it would have been thousands of dollars of retooling and getting the new mold done, weeks and weeks of waiting for the new product to come along.
Now, one of your other success stories involves a father who had a child that had a amputee, a hand that was missing. Tell us a little bit about that story.
Well, that's the RoboHand project. It's a project that we've supported, and it's actually an interesting story. Originally, it was a woodworker in South Africa, and he had amputated by accident 4 of his fingers in a woodworking accident. He went to go get a prosthetic hand and discovered they were about $50,000. And he couldn't afford that. So he went on a quest to really, he said, I make things. I can make new fingers. He partnered with somebody in Seattle, Washington, Ivan Owen, who is actually a hand prop maker for movies. And the two of them each got a MakerBot and collaborated 10,000 miles apart. And within 3 days, they had actually a fully functioning hand. And then within 2 weeks, they were actually fitting people with them. So Rich in South Africa fixed his own problem and created fingers for himself. But it was actually a neighbor of his, a 5-year-old little boy that was born with a birth defect called amniotic band syndrome, where he was born with some little nubs instead of fingers. And when they saw what Rich had done for himself, Liam's mother came to him and said, could you do this for Liam? So Liam was only 5 years old. He would never ever be fitted with a prosthetic. They're too expensive at that age, and kids grow out of them like sneakers. So they created a little robo-hand for him. And what they didn't realize was that this is a very common birth defect, and this is a very common issue for people that have lost fingers from illness or injury or accidents. So all around the world, people have been able to now make robo-hands. They uploaded their design for free on our website, Thingiverse, so anybody around the world can now download it and 3D print it if they have a printer. A whole community has set up on Google Maps, which is terrific, that have said, we have 3D printers, if you need a robo-hand, we'll make it for you. So it's really been this incredible movement to help people all around the world, and we've been very excited and proud to be a part of it.
This is going to create extraordinary innovation.
It does, yes. The exciting thing about 3D printing is that you can create something today that didn't exist yesterday. And that's actually one of our favorite things to do when we go on our website Thingiverse every morning, is there's new designs and new creations that didn't exist before.
And it wouldn't have been possible if it wasn't able to make a prototype inexpensively, quickly.
Right.
I mean, before you were talking about the robo-hand. A prototype of that level, again, as you talked about, $50,000 to make one, but the prototype itself would have been 10 times that.
Right, and the actual final product 3D printed on a MakerBot is probably about $5 in PLA material, and then some of them use other hardware to help give it strength, and so it's about $150 for the total hand.
Versus the 50,000 of what they were asking.
Yes, and medical areas for 3D printing are really exploding right now. I just heard yesterday of a story of a little dog that was actually born and couldn't walk, and most of the time, if a dog is born and can't walk, it doesn't make it.
It's euthanized.
It is. And an engineer heard about this, and he 3D printed and designed a little harness with little skateboard wheels for the dog, and now the dog is mobile and living a really happy life. So, you know, things like that are incredible, and they're transforming lives. We hear about 3D printing that they're making stents for tracheas that are saving babies' lives. We have surgeons who are actually modeling body parts and organs and tumors and such before they do surgery, because it actually minimizes the surgery time and it saves patients' lives.
I understand that even Lockheed Martin is using your product for the new space telescope.
Right, so Lockheed Martin is a big customer of MakerBots, and they're another great example. So they were working on the James Webb Space Telescope, which is replacing the Hubble telescope in 2016. And they could go out and they could do the traditional route of prototyping, but they were, again, finding it to be very costly and very time-consuming. They had an issue with the James Webb Space Telescope that they needed to do some testing of some components while the actual telescope was being cryo-tested. They used their MakerBots and they actually recreated all of the housing for the cameras for the telescope. They found out that there was actually light leaking into a spot that would have ruined
the entire telescope.
The whole project. And then they 3D printed a little baffle that went inside of the housing for the cameras and the telescope, and found that that solved their problem. So while the actual telescope was being cryo-tested, they couldn't get to it. So they 3D printed a replica that solved the problem. When the actual telescope came out of cryo-testing, they knew exactly what they needed to fix. It's done.
Saved billions.
Saved
Billions.
Millions or billions. Yes.
Taxpayers were happy.
Yes. and time too. I mean,
Absolutely.
that project has so many different components and
Applications and what it means for science.
Right. So there's so many different exciting stories. I mean, the medical area I mentioned earlier was that we have a customer in Boston called Rest Devices, and they make little baby onesies, and they actually 3D print a little clip that goes onto the baby onesie with electronics inside of it, and it monitors a baby's heart and breathing rate, and you can get that data on your smartphone. They actually have saved more than, probably close to $200,000 3D printing on their MakerBot.
To design that product.
Design that product. They were graduates from MIT. They were students with a really great idea. They had no financial backing when they started this project, and they would have never been able to go to market had they not had a MakerBot.
Hence, also, it allows the product to be more inexpensively sold to the parents.
Absolutely.
And parents going to have the peace of mind of knowing their child's okay when they're having medical issues.
Right. If you have lower cost to your prototyping, then that cost is going to translate into the final product. One thing that we're very proud of is that we actually manufacture here in Brooklyn, New York. So we always say that MakerBots are made with Brooklyn pride.
Fascinating. Thank you so much for all your time today, Jennifer. Manufacturers are beginning to realize that they have a lot of risk involved when they have manufacturing plants all over the world and one plant provides one part and another plant provides another. This increases their risk dramatically. Things like civil unrest, weather delays, a breakdown of a particular plant, all of these lead to production delays. One part in a major manufacturing process shuts down the entire assembly line. So companies now are beginning to rethink the proposition that they've used in the past. Let's outsource everything to the cheapest supplier. Because the cheapest, as we learned from wages, isn't necessarily the most productive. But there are other reasons also that are beginning to call them back home. When they left to begin with, we had energy prices in the United States that were significantly lower. Worldwide oil prices were less than half of they are now. But for the last 20 years, oil prices have been consistently rising, and we really don't see that that process is going to stop long term. So now they're beginning to rethink it also from the issues of what does it cost to get that part out of Malaysia or China? They're beginning to think the actual cost of transportation is overcoming the benefits of having it manufactured by the cheapest place in the world. All of these things together are marrying in a new event that is making companies say, I need to rethink my location. And the United States, for the first time in 40 years, is beginning to look attractive again. As manufacturing companies move back to the United States, they need manufacturing suppliers to assist them in their process. This is where the small regional companies start to bloom and blossom. An example of one is a company called Autometrics. It's based in Grass Valley, California. This particular company manufactures industrial cutters. Now, they have opportunities that are going to blossom. Autometrics is able to send out salespersons to the new companies, not only gaining new customers, but they actually can visit their current U.S. customers, spend more time there, and have reduced costs because now these costs are spread among more customers themselves.
The other thing that we find when we do machine installs for our customers in the U.S. is a strong understanding that matches what we're doing. So as we sit here and say it's important for us to have high quality products that are made in the U.S., our own customers who are also manufacturers, it's important to them to have high-end products made in the U.S. And they're maybe even more on the front lines where they're trying to sell kind of a consumer level product at that point to an America that has a choice between a consumer level product from China and a consumer level product from the US. And it's their job to sell their quality, their support, their everything to the consumer at that point. And so when we go into their shop and they're able to control their costs change their profit margins by bringing automation into their business, they're ecstatic because they're now able to not only be confident in their quality, but also control their costs. It makes them more competitive as they go up against imported products on a consumer level as well.
The real benefit here is the innovation process and the collaboration that occurs when you can visit your customer more frequently and actually see their needs firsthand versus trying to go to China and see something briefly and you have a communication problem. As innovation and visits and thoughts are shared, new products come forth, new uses come forth, and all this collaboration, well, it leads to the number one issue these small manufacturing suppliers want: more sales. Even huge multinational retail stores are seeing the potential of U.S.-made products. Walmart, for example, just 2 years ago pledged to buy more than $50 billion more in U.S.-made products, recently upped that commitment to $250 billion, a five-fold increase. Apple is opening plants once again in the United States. Apple closed its last American computer assembly plant in Elk Grove, California, about 10 years ago and shifted its production to contract manufacturers in Asia. The company had given up on making its own products and outsourced the work to subcontractors such as Foxconn. Now that decision is starting to be reversed. Apple recently announced the construction of a new facility in Arizona, creating more than 2,000 jobs. This new plant will make components for Apple products, and it will run on 100% renewable energy. Google has joined the likes of Apple and along with Samsung. Both have opened a new site in Texas. General Electric and Caterpillar have also been opening new plants in various states. And of course, we cannot overlook the massive new battery plant that Tesla has announced. Texas saw this trend coming, and it adjusted its policies to encourage such corporate movement. Their economy leads the nation in new job creation. Wise and forward-thinking governance can and does improve economic conditions. But it's not just huge multinationals that are coming back home. Miss Lee, founder and chairwoman of a Hong Kong-based boot and shoe manufacturer, Merchant House International, Inc., with factories in Asia and other parts of the world, opened a U.S. plant in Jefferson City. The return of any shoe manufacturer to the U.S. was unthinkable even in the most recent past. She started out with a modest investment of $5 million in her new plant, but she already has plans to double that investment within the next 2 years to more than $10 million. So what can the U.S. right now do to assist in the American reshoring of its manufacturing companies? The U.S. needs to address its substandard educational system. Middle-class jobs cannot return until middle-class skill sets are abundantly available. The factories of the future are not all robots. Critical thinking skills are and always will be needed to compete successfully long-term. So our next series will be exploring what does the United States need to do to improve and enhance its educational system. How are we going to compete in the future? We must have an educated workforce, and that will be our next two-part series.
The return of U.S. manufacturing is being led by new methods like robotics, 3D printing, and green remanufacturing. Today's factory workers are quality control inspectors, specialty chemical workers, engineers, and computer technicians. The jobs are safe, clean, and very much middle class. Manufacturing has returned to the United States, and it is definitely one of the industries that is showing the way forward.
As you can see, manufacturing really is part of the way forward. Thank you.
Thank you for your time. If you have any questions, please call 530-272-7500.